What's up, guys? Tim Halstead with DragBoss Garage, Friday Night Live. Yeah, it's a little early, about 14 or 15 minutes early, but I decided to get on a few minutes early so I could throw some shout-outs out there so we're not taken away from the technical aspect. It's been a while since I've done a live chat. I think the last one was April 11th with Cam Stanley. What a show that was. That was really good. I apologize for the beginning of that video, or excuse me, the live chat, where it was kind of blurry. The streaming was not adequate. And hopefully I don't have any issues here because I had to take the computer apart and fix some tower that's inside there, like a little cooling tower, take it off, blow it off with some air, put it back on there, and now my computer's back up. But so hopefully no issues with Friday the 13th, but welcome everybody. Mark Campbell's going to be on here at 7 o'clock. He's the one that designed the Holley intake manifolds, like the Strip Dominator, Street Dominator series from like the mid 70s. He also was key in getting the 1050 Holley Dominator into production, or fine tuning it, so to speak. You watch his live chat, you get a ton of information on carburetors from him. And he's also builds engines, a master tuner. He'll tell you some stories about that. He gave me we were talking about this, and then next thing I know, he emails me, which we're going to kind of go over, and I may make a separate video and make it available, 10 pages of tuning high-performance race engines. So he drafted this and sent it over to me. So we're going to kind of go off this. It's pretty cool. So let's just see who's up here. Bill Fioretti. I'm sorry, Bill. It's Friday. I know you do stuff with your family, but we'll get it at a time when we can all be here together. Gregorius Anomalous, good to see you here. Arniel Ford 66, good to see you here. Bruce Colton, good to see you. Preposterous Walrus, nice trailer. What did it run? I haven't ran that yet. It's coming up. Wait till, if you pay attention to the channel, you see me building the car, redoing a few things, motor plate, custom headers, slider suspension. So, but he gave me this. But let me do this because we only have a few minutes. But I'm pretty happy, and I got to give thanks to people that send me things, because I get a lot of things in the mail, and it's amazing. I just got that XE block that is possibly furnace braze from Mike Shreve. Then he sends me a set of pistons and a bunch of gaskets. And the head and the back, you'll see that's a whole other video. I'm not going to even ruin that surprise. But Chris Palnick, he has that 64 Fairlane that runs a Cleveland iron heads. He sprays it. The thing's running in the 8s. I forgot how fast now, but there's a video on here, and I'll try to hook it up to this. But Chris sent me a package. He has a race team, Reptile Racing. He sent me this awesome hat. Thanks, Chris Palnick. He also went to town and sent me not just one, but it looks like a half a dozen T-shirts that he had made up, which I needed to. Reptile Racing. Try to hold it up to the camera. Not good with positioning. Here. There you go. Thanks, Chris. I appreciate that. That's awesome. My whole family will be able to wear one. But at least I can talk better now. Anthony, good to see you. B&R Racing, that's cool. John Gallant. So thank you for that, Chris. I also hooked up with a buddy, Steve, from Marblehead, Ohio. He hooked me up with some guide plates in the Ford box, the original Cleveland guide plates. Those are kind of getting rare, so I appreciate that, Steve. He's going to hook me up with the guy that made the headers for the GT40, for Shelby's GT40 back in the 60s. What was that? 66, 67, you know, with Le Mans, 24 hours there. The guy only lives 25 minutes from me. I can't even believe it. And he can weld anything. If you can bring it in, he can weld it. Doesn't bring on anything that you can't carry in your hand. Hi, Daniel Wilson. Good to see you, man. Let's get this DBG party started. We are. That's for sure. Bill Cook. Now, I bought some intakes off Bill Cook. He sent me all these gaskets for tunnel rams, for like the YN tunnel ram. These are hard to come by, that fit nice. You don't have to cut them. So thank you, Bill. Appreciate that. A couple other people that are from Canada. Braden Hager. He races a black Fox body Mustang, like an 86 with an iron-headed Cleveland. That thing's, I think he just ran a 612. That thing's cooking. He did some intake work on it. Then you've got Dave Silva. He's got the Buick Grand National with a Cleveland. He's spraying. Those guys are from Canada, so welcome, guys from up north. John Salvatera. Now, I did that thing on Camp Stanley, and he sent me the Super Ford magazine, and I know I have this somewhere because I remember that car. I love that car, Boss 429. But it's got Camp Stanley's card here, so I'll put some pictures somehow in another video. Thanks, John Salvatero. There it is right there. And it shows the car being built. That was a body in white from Ford, so that's pretty darn cool. He also sent me this, the 1989 Ford Performance equipment catalog, you know, motorsport stuff. I love looking back there and seeing the heads, the cylinder heads I had. You can get a lot of information from these old catalogs. It's when the Fox body was just starting to get underway in '86, you know. So thanks, John. He also donated money to DBG. Michael Giglia, he's from Down Under. Now, he sent me an article, which I'm working on now, but this is from, I don't want to pull it out, but it's from like CarCraft, I think it is, in 1969, where they have introduction of the Cleveland. And that's going to a video I'm doing. Hey, John Wilborn, it's good to see you. How's it looking for you to make it to the, I don't know. You know, my car, I'll have to put some pictures up, but I talked to my chassis guy today, and he's got the headers almost done. Wait till you see these, man. They are wicked. It's a work of art. And so that's getting done. Hopefully within the next few weeks, I want to get to that Ford event. If I go to that Ford event and I don't have any issues, and I only race a few times after that here and there, so maybe I will roll out there, John. We'll see. Hey, Dean Stevenson, I'll be keeping my big mouth shut. I'm going to learn me something new for this donkey. Hi, y'all. That's pretty funny. You're a very opinionated person, Dean. You have a great knowledge base. You like to share it, whether it's all true or it's all evident. I don't know. I don't even worry about it. It's about sharing knowledge and letting us understand it and try to look at things from a different perspective. So Mike Shreve, there's his Mustang. I got a little video going on for him. It's awesome. He's traveling right now. So we got a place to put those pistons, I'll tell you. Philip Bailey sent me, and I don't have it here, but he sent me the CCing, the Moroso acrylic CC measuring device, you know, that you put over the cylinder head, and then you can use a cylinder, graduated cylinder, and put the fluid in to measure the CCs. So he sent me that. I appreciate that. Tarzan Mo, quick question. I don't know, man. I'm just keeping going. If I can read it and do it, I will. Looking forward to more pro stock. It is, man. We got a lot of stuff. Now that I got that other block, that XC block with the bushings in it, I think we're going to make a pro stock motor out of that. And I got a couple sets of pistons I can choose from. And we got the cylinder heads now. Those things are killer. Wait till you see these. It's going to really blow you away when I show you what I found out. Bill Fioretti, he's got a body shop and restores Mustangs, Boss 429s, Boss 302s. Great guy. We chat here and there. He sent me some stuff. I still have to go through it. His car was in a magazine. It's really cool. And I appreciate you, Bill, checking on me and making sure everything's cool. The DragBoss 427. Just a quick insight on that. Now, the block is at BS. I talked to Tony a couple of weeks ago. They're getting ready to do the machine work on it. I already said this in another video that we order the pistons. It's going to be about 15 to 1. I don't really want to go much more than that. I should be able to make 850 horse with that, plus the cam and the heads that we have that Darren ported the secret A3 heads. And the intake, we're going to use that Scott Cook intake. Scott said he was going to make an intake or hook me up somewhere along the line. Who knows? You know, this engine's not going to be done next week. We're talking about a few months to get it together. So, and I'm in no hurry. You know, the Cougar's almost done. That 409, you already saw the dyno that's on here. I love hearing that thing rev. So 6:56. So I still have a few minutes. Let's see what else we got. I've been talking about that a couple times. I hate saying the same thing, but having no results. But I don't want to forget, so that's probably why I mentioned it too. He apologized. He's got some stuff going on, but we're going to hook up. No Name Nationals, that's a big event that's going on, and that's what John Wilburn was talking about. Unity Motorsports, Uncle Tony's Garage. You know, a lot of guys are going there. Barrow's Garage, Motor City Madness, Mike's Hoopty Barn. I like to watch those guys' videos. And I had put up what did I just put up a video of? Can't remember. Oh, doing a hinge on a 1940 Ford. You know, that's the thing about a garage. Lots of things happen in the garage. So when I put up videos on this channel, you know, there's a couple I might put up that aren't even really drag race related. It's just stuff I like to do. And maybe you could get an idea that may help you. Let's see what it says. How do we peer pressure you into going, sir? Into going where? No Name Nationals? Well, let me tell you something about peer pressure. I don't get stressed too easy. I work in an emergency room for the past 9 years and open heart surgery for 13 years. So I don't get too worked up about much. Except for when my kids don't listen. Sometimes that'll get me going, but not much. Zeus is doing well. I've incurred some injuries from him. He hit me head on in the tibia. Got a huge hematoma in the leg from that. Bit me in the hand. I got a little bit of an infection. I had to open it up with a knife, scalpel blade. So he's one of those guys I think we're going to get some training because he's definitely so smart. You got to be a smart guy to own a Doberman, that's for sure, because they can outsmart you. Yeah, that No Name Nationals. I don't know. You know, that's a haul for me to throw it on a trailer and go out there and try to find a place to stay. I don't know. It just depends on if the car makes it down the track without any issues. If it is, then I used to race back in the day, man. I throw my car in a trailer and drive from New York to Pennsylvania to wherever, Ohio, back to New York. I was all over the place. Those days were when you're single and that kind of thing. But it's tough as you get older. It's harder to race. Hey, what's going on, Andy? So here's what we're going to do. It's 6:59. We're going to bring Mark Campbell on board. Now, he's going to talk about, I'll bring him on. We don't need to. That way you can kind of interject. It's a barrette. That's one of the accessories. Right. Graduated barrette. Unity, sir. There you go, baby. Mark.
How you doing?
Hey, it's good to see you.
Good to see you.
I might have to work this. Let me adjust this camera a little bit because now with two people, I want to make sure that we can see everybody. There we are.
Sure.
Perfect. So with no further ado, I introduce Mark Campbell, engineer extraordinaire, designer of fuel systems, and other apothecary of madness, we'll call it. So we had talked before, we did a live chat before, and we had talked about the Holley Dominator and the origins of it and what changes that you did to make it work better and perform not just for the out-of-the-box crowd, to fine-tune it, the things that you've learned from your vast experience. So we learned about that. We learned that you did the intake manifolds for Holley, the Strip Dominator, Street Dominator stuff. And I think that was like mid-75 from my memory, because I remember when they were coming out.
Yeah.
You know? So the other thing that Mark does is he's an ace tuner. He does a lot of tuning. He's built engines. He told me a story about going there and because the race is in the first 60 foot. You said the most important part of a carburetor is the idle circuit.
Correct.
I mean, that needs to be clean because when you're sitting there against the tranny breaker or whatever, however you're putting that against the load, you want that thing crisp. You don't want it loading up and then next thing you know, bogging coming out of the hole. So these are the things, like you said, warm-up plugs. I never put warm-up plugs in a car in my life. I'm the kind of guy that I turn the key, I go racing, I win or lose, I put on the trailer, I go home. That's how I want my car to run. I don't monkey with it at the track. Very rarely do I do anything to it. I mean, I go years without doing anything, nothing. I just, as long as the motor stays together. So,
well, there's all types of things of different types of racing too. You know, I mean, years ago, Bill Jenkins wouldn't bring a car to the starting line unless he was up to at least 225 degrees. You know, today there's ways of building heat in the engine. What we want to do is maximize the amount of heat on top of the piston right after top dead center. And with today's, the way they run the races and everything, that's, you know, so you were talking about 15 to 1. There's a lot of guys running 17 to 1 and stuff.
oh, yeah.
Stuff. Yeah. But the reason they do it, they're getting the heat in the combustion chamber from the compression. They can't waste the time between runs and everything that's going on to fire the engine up, bring it up, warm it up, and everything else. And they have to go through a consistent procedure when they start the car, how fast they run it, you know, what amount of time they take to warm up the tires, stage it, make the run. And you know, one of the things I put in that little thing I sent out to you is we were doing some testing on Victor Cagnazzi's car years ago at Charlotte. Told you last time we talked this, it was like 4 or 5 years ago with Erica Enders. And
Yes.
time flies, you know, it had to be 7 or 8 years ago.
Okay.
But the fact is, those guys they must have made 6 or 7 runs that day. Well, you can't have an engine warm up and then try to work on it when it comes back. After they made the run and came back, pulled the valve covers off, I hit the exhaust spring and the exhaust valve with an IR gun to see how hot the exhaust valve was. It was 109 degrees. 109. Huh?
That's
no,
not
you can grab a hold of it with your hand.
Right.
Threshold of human pain is 140. So that engine, you know, throughout the run, it didn't get hot. So they could run a fairly warm plug in that engine despite the compression, because they didn't put any time in the motor. You know, the total number of RPMs that engine ran from the time they lit it off to heating up the tires and making the run and pulling off the track and shutting it down, hell, there probably wasn't 800 to 1,000 RPM.
Now, I'll tell you my experience.
Revolutions, not RPM.
Yeah.
800 to 1,000 revolutions. It just didn't go that long.
Let me tell you what I do, and then other guys here that race might be able to put it in perspective. Here's how I think. Running a Cleveland that's got a filled block, so it doesn't have a lot of water in it, it's filled block. Mm-hmm. The problem that you worry about with them is the oil temp getting hot. So just keep that in the back of your mind. Now, if I'm going there to race and I start the car up, I let it warm up to about 150, 160. I shut it off and let it like heat sink, let everything get to the equal temperature. And then when I'm ready to go up to the line, hopefully it's about 150 to 160. Again, I just drive up there. When I leave, my car runs the best if it's like at 180, 170.
Okay.
Water temperature. The oil's probably, well, looking at the gauge, the oil's like, I can't remember if it's about 180, 190, somewhere in that age, a little bit hotter. And that seems to run the best. If I try to run my car at 200 or 220, that thing doesn't want to run.
Well, but that's because the heat range and stuff like that. If you're going to run 220, you're going to make more power at 220.
Okay.
But
220 water temperature, engine temperature.
You'd make more power at 250. NASCAR.
Okay.
NASCAR cruises their cars at 240 to 250. Okay. That's where they run those things.
Yep.
And you can run it with today's oil and everything else. What kind of oil do you run the engine?
Just the old Brad Penn 2050 that I've been running for 40 years.
I mean, it's great oil, but you can run, you know, what's important in oil is not the viscosity, it's the film strength. And modern synthetic oils have higher film strength than the old race grade oils and everything else. So you can run a 020 or a 520 without any problem at all. Years ago, when I worked at Gale Banks Engineering after I left Holley, we were running in big block Chevys on offshore boats, you know, for water skiing racing and everything. We were running 520, 530 oil in those things. And running 40, 45 pounds of oil pressure. That's all we were running. And we didn't want to waste power turning the oil pump. And those things, you know, those things got out and they had to run. But you can't, like you're saying, it runs best at 180. I don't doubt you a bit with what your setup is.
Right.
But I'm saying there's probably more horsepower
Yep.
if you let it get hotter. What oil temperature are you running to?
I've always been told to try to keep it away from 215, right around 2.
You wanted at least 212. The reason you wanted a 212, that's on any car, okay,
Yep.
is because the atmosphere has water vapor in it.
Sure.
If your whole crankcase is on water vapor, if there's dew on the grass, you got water in your oil. You know, you got the only way you get the water out of the oil is to run the engine hot enough to boil the water out.
Right.
Okay. And oils, modern day oils, don't even start to deteriorate till you get around 300 degrees. So you really
are you talking semi-synthetic, synthetic? You're talking
even a mineral oil is good to 270, like what you're talking about with the Brad Penn. That's good to 270.
Okay.
There's no problem there. You know, we ran. I back in the 80s, we didn't have the lightweight steel connecting rods for circle track racing. I mean, I did a lot of drag racing years ago, but I ended up, you make more money as an engine builder in circle track, okay? So I built a lot more circle track motors than I did drag motors. And I ran a lot of aluminum connecting rods in the 80s to get the rotating mass down, you know, get the throttle response and everything. And so I ran a lot of aluminum rod motors, and they held up great. They didn't go, I used the same rods for 3-4 years, you know, no problem at all. And the key to making an aluminum rod last is you got to keep your oil temperature under 225 or whatever. So we ran an oil cooler to keep it under 225. But as long, you know, 210 to 225, it was fine. And there's no issues there at all. I'd never worry about that. For running the circle track races, we ran a lot of dirt. Dirt was the main stuff we ran on. Ran a limited late model and late model. And in Western Pennsylvania, Pennsylvania Motor Speedway and Motordrome in Jennerstown when they were dirt tracks. And we ran 3 nights a week. I'll tell you what, you want to run yourself ragged, race 3 nights a week with the same car and having it ready. Okay. I mean, you don't have a spare minute.
I mean, you're not pulling that motor down, are you?
No. We ran 1 year. We were really lucky. We didn't have that many rainouts. We had 52 features we ran with the same engine. And that doesn't count all the heat races and all the other stuff goes with it. 52 features. That was an aluminum rod motor. It was a steel head, angle plug head, 13.3 to 1 compression. And we cruised it, you know, we'd come off turns at say 4,000 and take it up to 72, 7,400 and then cycle back down and around. But we cruised the engine. We didn't go out on the track until we were 225. And at race speed, we were 245 to 250 all the time. Now, the people we were running against, they were always running their engine at 180. I mean, they were doing everything to keep it down at 180. You know, got to keep it at 180. And we'd come in, and they were having all sorts of issues. And we'd come in, and they'd look at our temperature gauge and say, "How can you do that? You know, you're going to ruin your engine." It's hold up well. We're winning. You know, and we aren't having any issues. And we didn't go to the track and mess with anything like you're talking about. We came off the trailer. We just checked the coolant, you know, all the fluids. We fired it up on street plugs, let it get up to 180 degrees, shut it off, went and got a Coke, let the headers cool down. Yeah. Then took out the street plugs, and then put cold plugs in, and then fired it up and made sure we kept the engine at about 160 to 180 degrees all the time. During heat races and stuff like that, we'd fire the engine up regularly and keep the damn thing hot, keep temperature in the heads, so that when we went out on the track, the plugs were clean with the cold plugs. Because if you want to run a high compression motor for a significant period of time at a higher speed, you got to run cold plugs. I mean, we ended up at a couple different tracks where we had the wrong gearing in the car.
Yeah.
So we ran in third gear rather than fourth and turned the damn thing 8,400, you know, and thing held up. It held up fine. You know, the other thing people don't understand is when you get into pistons, I had this explained to me by one of the main engineers at TRW years and years ago. And if you took a look at all the and I never saw an article written on this. If you took a look at all of the catalogs at the time, they had replacement pistons, high performance pistons, and racing pistons.
Yep.
Okay. He said, they're all different. He said, they're all designed different because pistons are not round. They're what's called cam ground. They're bigger diameter across the thrust faces than across the pin bosses because the pin bosses have more material. They'll grow more across the pin boss as they get heated. Also, they're barrel shaped, so the top measures a smaller OD than down at the middle of the thrust face.
Right.
And a replacement piston is designed to get square, the top get out to square with the thrust face, and the piston become round at about 1,800 to 2,000 RPM under about a quarter throttle. Okay, like regular daily use. A high performance piston was designed to get round at about 3,000 RPM, 3,000 to 3,200 under about half throttle. Okay, because a high performance piston was considered, they figured you had 373s or 410 or 456 gears in the car. And so you're going to be running an average higher speed out on the street. So that's where those pistons would get round. And then a racing pistons didn't get round to 4,800, 5,000 RPM. Okay, you need at full throttle, you need a lot of heat. So I saw a lot of guys, you know, try to run racing pistons on the street, and they couldn't figure out why their engine was oil or why they didn't make as much power. And it's because the pistons never filled the cylinder to seal it. They didn't get round because they weren't putting enough heat into the engine. And then you had there were a couple different blank suppliers like Wiseco and TRW and stuff used one supplier, and the West Coast used Alcoa as a supplier for blanks. And those differences had different thermal expansion rates, you know, and that created issues too. The West Coast pistons, you had to run more piston to wall clearance than on like a TRW or a Wiseco or something like that.
Wow.
I always like to run as tight a piston to wall as I could. And then, you know, what came out, at least for circle track, and it can be used in drag racing, the end all, the true street strip piston was when United Machine came out with the hyper-eutectic pistons. Because those damn pistons just don't grow. And we set up our race engine at 1.5 thousandths piston to wall with that. Okay. Generally on a forged piston, you'd run 6, 7, maybe 8 thousandths piston to wall. Set that sucker up at 1.5 thousandths, take that sucker up to 72, 7,500. Never had any scuffing, never. But the key with those things was you had your end gaps, they don't absorb heat. They reject heat back up into the combustion chamber, that hyper-eutectic alloy.
Yeah.
But your top ring grows much more than on a regular alloy piston. So you need a much bigger end gap on the rings. And where a lot of people went wrong, they would try to run the standard end gap they ran on a regular forged piston, and they'd break the head of the piston off, and they'd say those things are no good. I never had an issue with hyper-eutectic. I mean, I beat the hell out of them. Never had an issue. Oh yeah, yeah. Greatest thing since sliced bread.
What? I think they suck. I always thought, I mean, I wouldn't run those. I said to myself, if you're going to run forged pistons, man, you got, you know, really.
I ran those things over 8,000 regularly. You know, I wouldn't run them in a pro stock car or something like that, but I'm talking about a sportsman wanting to build something to do like what you're
500 horsepower, you know.
Go racing. Hell yeah.
Okay. There's let's see here. There's 85 people here. We have a quick shout out to Ken, Teddy's Gun Shop there. Let's see who else is here. Gregorius, yep. Dean, we talked about. Billy Manilli, Top Fuel. Let's see. Top Fuel dragster crank makes around 550 revolutions in 1/4 mile.
Right.
Wow.
It isn't much. When you think about the RPM you're running just to bring it up to the staging area.
Yeah.
And a little bit of time you stage it and make the run. you know, you're probably under 1,000 revolutions total from the time you light the thing off till you shut it off.
Here, I'm reading your outline that you sent me, Mark. Let's see, it says 1, compression ratio on cylinder head. Combustion chamber design, including plug location and cylinder head material, also piston top shape.
Yeah, that really affects your flame speed, and that affects your ignition timing, what you're going to run full throttle.
Plug location, I never really thought about that much.
The closer the plug is to the center, that's why Hemis are so great, because the plug's right in the center, so the distance to the far edges is much reduced from something like where you have the plug way off in the corner. You know,
right?
Small block Chevys way back when they had to run 38, 40 degrees total advance at full throttle because the damn piston was out in the backyard. You know, it took all that time to get the flame all the way across the cylinder. So if you can get the plug in closer to the center of the combustion chamber, then the flame doesn't, you know, it's going to travel to all the edges much faster, doesn't have as far to go. And you want as quick a pressure rise as you can get short of an explosion. It has to be a controlled burn.
Right.
But you want to take all that energy in that air fuel mixture and turn it into heat. You got it, and you want to keep as much heat focused in that combustion chamber as possible.
Okay. Bore stroke ratio and connecting rod length stroke ratio. This is piston dwell time at top dead center and how fast the piston accelerates away from TDC.
Yeah, I mean, I'm a big fan. I hear people say, you know, you use long stroke motors and all this crap, and you're going to make more torque. I've never seen it on a dyno. I just maybe on a tractor trailer on a Cummins diesel that you're running 1,200 RPM, that may be a factor. But I'm a big fan on long rods, short strokes. You know, use the longest rod you can fit. Yeah, that reduces the side angle on as the piston's pushing up the cylinder and coming down. So it reduces the thrust, reduces the internal friction in the motor. And the other aspect is people think, you know, if you take the piston, think about the crankshaft. If you turn the crankshaft, take the crankshaft and turn it 90 degrees, how far down the hole did the piston go?
Not very far.
No, but I mean, you got, let's say you have a 4-inch stroke, okay? And the piston's at top dead center, and you turn the piston.
Half would be 2 inches, right?
Huh?
Half would be 2 inches. Half of it would be.
Half of it would be 2 inches, but it doesn't go half.
Right.
You got the connecting rod length on the pin this way, but when it's at bottom dead center, the pin's down, but you still have the connecting rod this way. So the piston travels more than halfway down in 90 degrees of crankshaft rotation. And the longer the connecting rod, if you plot the piston position, take a small block Chevy that has a 6-inch rod and a 3.48 stroke, and you plot the piston position at say from 10 degrees before top dead center to 10 degrees after, and watch how far it moves down.
Yeah.
Or 20 to 20. And you plot that. And then you do the same thing with a 5.7-inch rod. The piston on top of the 5.7 rod will move away from top dead center more. It accelerates away from top dead center quicker than the long rod. The long rod tends to hold the piston in a dwell time longer, allows the pressure to build higher, so you make more power. Okay, plus you have more power, you have less internal friction, you're just netting out a lot more. The other thing that happens when you plot this all out, there's computer programs for it. I've done it with a dial board gauge, so and a degree wheel. With the longer the connecting rod relative to the stroke, the piston accelerates away from bottom dead center faster. It accelerates away from top dead center slower, accelerates from bottom dead center faster. So that affects when you want to close that intake valve, when you close it as far as the intake mixture coming in.
Right.
When you're closing that. So the rod stroke ratio affects all of that with respect to what you want to do with your cam timing and everything. And to maximize cylinder pressure.
So you're saying with that longer rod, you're keeping it up against the head longer.
Yeah, keeping a tighter volume while that burn's taking place. Yep. So more
milliseconds. You know what I mean?
Milliseconds. Yeah. But as I say later in here, when you're talking time with an engine, time is crankshaft rotation. Okay, it's degrees of crankshaft rotation. It's in milliseconds. At a low speed, 2,000 RPM, the crank doesn't move that much. But at 7,500, it's moving a hell of a lot. You know, so time is always in crankshaft degrees of rotation, not seconds. You just got to always be thinking about where that piston is during the crank rotation. And that's one of the key issues, is because when that spark lights off, it takes a while for that initial kernel of flame to start.
Right.
It's like when you light a match, it takes us a
Sure.
little bit of time to get that kernel of flame to start. And the same thing goes on in the cylinder. And it takes the same amount of time in milliseconds, whether you're at 2,000 RPM in full throttle or 7,500 RPM in full throttle. Now, it's different if you're hard throttle. It takes even longer. But I mean, the more pressure you have in the cylinder, it makes that initial kernel flame start just a little bit faster, but not that much. So that's almost a fixed period of time that you're stuck with on that kernel of flame. And that becomes the limit, like when you get into Formula One or motorcycles, you're trying to run 19 or 20,000 RPM.
Oh, yeah.
Think how many milliseconds you have a piston up there, and you got to get that flame started, you know? It takes a period of time. Huh?
I can't even imagine it. You know what I mean? You see those motorcycles, 14,000 RPM, 15, you know?
Well, I mean, some of the Formula One stuff years ago, they were on 19,000. And so they were limited by how quick they could get that initial kernel of flame started.
Here's a good one. Let's see. Give a couple shout outs here. Street Fox, good to see you here. Let's see. Preposterous Walrus. Can you read that, Mark?
Yeah. What's the difference between a burn and an explosion? You had mentioned explosions are bad. I always assumed every ignition is a mini explosion. No, it can't be.
It's just a fast flame.
Yeah, it's a really fast flame. And as a matter of fact, what we have in a cylinder head is you have a flat area called a quench chamber that you have a very tight clearance between the top of the piston and the flat surface of the head. That's called the quench chamber. And as the flame comes across the piston, it runs into the coolness of that steel, that cast iron or that aluminum, and that quenches the burn before the end gases explode. So the flame lights off at the spark plug, and then it starts to propagate across the cylinder head. Yeah. Yeah,
there's a nice piston right there.
Yeah.
Quench like up here.
That's quench there, and that's squish there.
Yep.
That's called the squish area. And what the squish does is, as it's coming up on the compression stroke, it causes the air to tumble in the combustion chamber and help the air-fuel mixture mix well. You know, is what you want to do. And then you got a flame slot in there because that's to allow the initial flame to get started. But an explosion is just like dynamite and everything. I mean, that's just, you got a preposterously high pressure wave. And not only that, it's not just pressure, it's noise, but it'll drill a hole right through an aluminum piston right now. So the burn, it has to be a controlled burn. It's a very fast burn, but it has to be controlled.
Okay.
And when you start hearing knocking, tick, 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 or something like that, that's detonation. That is, the end gases are exploding, and you don't want that because that'll eventually destroy the piston.
I like this. So what you're saying is we should have stayed in math class. I can't.
No, you know,
you asked me that question. I'm like, well, let's see, half of a 4-inch stroke, so it's 2-inch. I mean, I can't figure that stuff out in my head. I'm like, what?
Well, there's programs available for all that stuff. You know, that you can just plug in what's your stroke and what's your connecting rod length, and then have it plot out how far the piston moves in degrees or half a degree or whatever you want. It's really interesting to put forward a lot of what ifs and check all that out.
Here's a good one. Mark, what is your opinion of the dual plug Hemi heads from the 60s? Legit upgrade or snake oil?
Oh, it's legit, man. Again, what you're doing, you got plugs spread apart. But what it's doing is reducing the distance the flame has to travel. And when that happens, a lot of people used to think, well, the more spark advance I run, the more power I can make. No,
Right.
You had to run a lot of spark advance because they were lousy combustion chamber shapes.
Yep.
The ideal combustion chamber is a Hemi. Okay, it's the ideal.
So compression with them.
Yeah, that's the problem. But that isn't all that big of a problem. I mean,
I understand.
The output you get from a little bit extra compression in many cases just isn't that much. The only way you get it is if you have it tuned to the nth degree. If you go for high compression and you don't understand the tuning, you're going to lose a lot more horsepower than what you thought you gained. You can make enormous amounts of very respectable amounts of horsepower with a 10-to-1 motor. I mean, when I worked at Crane Cams, we had a mule engine, a 355, and with a hydraulic roller cam, single 4-barrel, it had World Products heads on it, iron heads. That thing would make 480, 490 horsepower all day long, just as reliable as you could imagine. 10-to-1 motor. Okay, but we ran it warm, to do the things you need to do. And heat is power. Heat is power. And you want the intake charge to be as cold as possible.
Correct. Yeah.
You want everything coming in to be as cool as possible. And that's where, running methanol, it has a great evaporative characteristic where it cools the intake charge down, and that contributes to making more power. That's really where the power is in methanol. It isn't in the heat. I mean, a gallon of methanol has half the energy value of a gallon of gasoline. It doesn't have anywhere near the energy value. But it does have it's the cooling aspect. It has oxygen in the fuel, and it has essentially a higher octane. You can theoretically run a slightly higher compression ratio. But compression is no good if you can't tune to take the advantage of it.
Hey, big shout out to you, Terry Grover. Chad Spear, his father had bypass surgery yesterday, so it's good to see you here. He's got a question for you. He ports heads for a living. A lot of great work comes out of his shop. He's got a super stock car that he just built. Here's a question for you that he has. Let me get it back up here.
Yeah, I mean, I think, there's more innovation to my way of thinking. An awful lot of innovation really went on in stock and super stock. I mean, it sounds like, it's basic and things like that. But when you have a limitation in your heads, as far as port volume and things like that, you got to just have a more duration to get the thing in there, to get the air in there. You got to take advantage of it. It's one of the things there too that I've always struggled with. Dynamometers can be, if it takes a lot of money to run a dyno program right. Or when I say a program, I'm not talking a computer program. I'm talking a testing program. Because what you really ought to do is ABA test. You do a baseline test, then you make a change, and then you go back and you better check the baseline again. I mean, when we were doing the manifold program at Holley, we really screwed ourselves over big time on this original small block Chevy Strip Dominator because we had a calibration bar that went bad on us and we didn't know it. And we're running all these tests and we think, we're happy as a clan, we're making changes, things are happening. And hell, the calibration bar went back. We should have been, we went back to the baseline after we'd done about, 15 different changes. And go back to the baseline and it isn't even within 30 horsepower. I mean, it's totally screwed up. So we had to get the maintenance people in, and this calibration bar had to be the right alloy and cut just so and contain, it was a Heenan-Fruit dynamometer. But anyway, to run a dyno program properly requires a lot of money and a lot of time. I mean, a development program. And if you don't have the time and the money, I really think many times a dyno can lead you down the wrong path. The other thing that goes on in the dyno is you don't have negative pressure at the back end of the headers in many cases, like you would a car going down the racetrack. I mean, the air's coming underneath there, creating a vacuum that helps the suction. And that's why lots of times a dyno tune and what you end up tuning on the racetrack are two totally different things. People don't realize how the collector length and that signal, the exhaust, affects everything clear up through to the carburetor. I mean, I think I told you before about a problem with a Icona dragster that was just collector length. It showed up as a hesitation coming off the line, like a bad an accelerator pump problem on the carburetor. And what it was the collectors that weren't long enough on the header. Put 20 inches of collector link on, boom, thing left like a rocket, you know. It was absolutely amazing. But that, you could be on a dyno that didn't have negative pressure underneath that thing, and you wouldn't know. You wouldn't know. So anyhow, where I'm going with this, if you do testing on a small block Chevy, you'll find out you'll make peak power. If you got 6-inch long rods and stuff, you're going to make peak power with a lobe separation angle of about 104 to 106 degrees, somewhere in there. You will always make best power there, 104, 106. The question becomes, what's the throttle response? Dynamometers do not measure throttle response, okay? There's and I think I told you before, I have some concerns, and the concept is brake horsepower. When you had an engine on a Heenan-Fruit dyno years ago, and you want to test the power at 5,000 RPM, you pull the handle back on the throttle, open it up, you dial in the load on the dyno so that it's at 5,000 RPM. The engine's there, it's got its tongue hanging out. It can't make another RPM. You know, you read the torque, you read the fuel flow, and you got your brake specific, and you can calculate your horsepower. Okay, and you let off, you come back, and then you go up to 5,500 or 6,000, whatever. Today's computerized dynos, the engine's constantly accelerating. Well, if the engine's constantly accelerating, you don't have that thing braked at that 5,000 RPM point or at 5,500. They've got an algorithm that takes that into consideration. But I have played with camshafts, the same exact cam, ground on a 104, 106, 108, 110, 112 lobe separation angle. Okay.
Yeah.
And
it just moves it in a different RPM range.
Well, it changes your overlap. It changes,
right. Yeah.
Okay. Changes your overlap considerably. So as the lobe separation angle goes up, you have less overlap. Boy, does that affect throttle response. Okay. So, you know, the people we raced against, we had a lot of success. People we raced against always ran 106 lobe separation angle. Okay. Because that's where your maximum horsepower is. But I built my engines at 109 or 110. I told you before, they idled pretty smooth and everything else.
Right.
But I always had throttle response. And when I'd set my mixture screws the way we're going to describe later on, I'd hit that throttle at, you know, I'd get that thing up at 220 degrees and hit the throttle and just be, it barked at you like an injected alcohol car. It wasn't, it was, just really crisp. You know, that's what you want. You want that sucker to just tremendous throttle response. And I just don't believe there's any way of measuring throttle response on a dyno. And you got to grind a series of cams. And I was fortunate, you know, I've been fortunate all my life to be able to do a lot of this stuff on a lot of other people's money. And, you know, the company's money or whatever, and not have to worry about blowing up an engine or whatever.
Right.
And you know, I think a slightly wider lobe separation angle in many cases gives you throttle response, especially in a circle track car, dirt track racing. I mean, I know we're into drag racing here, but I'm just talking to those people that are out there. I wouldn't, you know, we aren't racing dynamometers, you're racing cars. And so you need that throttle response. And to my way of thinking, 109, 110 lobe separation angle on a 6-inch rod small block Chevy is pretty damn good.
Well, I'll tell you what Darren Morgan told me. And I look at it like this. With the Cleveland, I mean, you're crutching that head because of the way they were made back in the day. So you're changing your cam timing, your duration. let's say the intake center line going from, you know, if it's on a 110, you put it in at 106 to pick up that low end.
Well, that's where you set, but that's where you set your that's different than the lobe separation angle.
Right. I know what you're saying. Yeah. So they're usually like on a 110 or something, 109. Mm-hmm. If those heads get improved with flow, you need to increase that to, you know, 113, 112. Okay. These motors that are making 800 horsepower, 900 horsepower, you know, they're like at 112s.
So that's at the intake center lines at 112.
Right. No, lobe separation angles at 112.
Okay.
Yeah.
Well, I can believe that. I can believe that.
Because as a head flow improved over the years, instead of being at a 109 or 110, now they're up to 112 and 113. These heads are flowing 400 plus CFM, you know?
Yeah. And hey, and just a warning out there to all your listeners. I mean, I'm an old geezer here, okay? I haven't done any tuning on engines in the last 8 to 10 years. Okay. So I mean, but the concepts are all the same. You know, the concepts don't change. Whether you have an ignition box that can provide certain things or whatever, that's that a distributor no longer does. But if you understand the basics of how the distributor is supposed to work to begin with, that helps you in setting a box up and things like that. And
most of the subscribers that are watching this are more like us, old school. You know what I mean? When it comes to the new data loggers, I mean, I'm just learning about it. I mean, the channels and I'm thinking about getting one. It's all great knowledge that can make your race package tighter. And that's the thing that we're talking about, tuning, you know. Did you ever work with David Vizard?
Yes, many. I've talked with David an awful lot, yes.
He, my buddy Andy that has a Unity Motorsports garage, they live nearby, and he does a lot of head work for them, does a lot of engine building with them, all kinds of stuff with them. They have great live chats. David, that guy can talk, I'll tell you, you know.
He can talk. Yeah, you know, a lot of those guys from England. There was another guy that had what's his name? Gordon Blair. Gordon Blair had developed a program, Foursquare or something like that. It was a CAM design program. And you talk about a talker. And he taught at the Queen's College of Belfast, you know. And he was right there. I'd like to put David Vizard and Gordon Blair in the same room. Gordon's dead now, but they're both very good talkers.
All these people are asking questions. We've been just talking away. Let's see. We talked about the explosion, like detonation. Let's see. Oh, this one's good. Just came in. As always, thanks for both you and your info. Could listen for hours. Thanks, Ben. We appreciate it. John Elliott, great subscriber. Yep, there you are. Can't tune the dyno. We know that.
Yeah. I'll say that. I want to say this too, right now, just to throw things out. When it comes to like for street performance, a street or street strip car, a person really needs to think about everything. And again, this goes right back to spark plug heat range. When it comes to tuning a car, the spark plug heat range is the single most critical thing to tuning a car. Okay. And you got to decide, because it's going to determine how long you can stay in it, how hot you can run it. If you want to make power, you're going to run the thing hot. Okay. Spark plug heat range is absolutely critical and absolutely the most important thing. And when you're going to build a street performance or a street strip car, you're always better to keep the compression down around 10 to 1. If you have aluminum heads, maybe 10 and a half. You know, because if you build a 12 and a half to 1, you need cold plugs. If you put a plug in that won't foul out on the street on a 12 and a half to 1 motor, you'll never be able to get the power out. You'll never be able to tune it to get the power. The only way you'll be able to do it is shut it off, put cold plugs in and reset everything. Because a spark plug, I mean, a good place to go is on Autolite.com. They've got an explanation of where the temperature ought to be for a spark plug, where it operates. You know, they have to be at least 700 degrees on the cold end and about 1500 maximum on the high end. And so the heat range of the plug affects that. A cold plug dissipates heat very quickly from the combustion chamber. And so that's what you want for high performance engines. You got to get that heat out of the plug so it doesn't stay hot and become a pre-ignition point.
Ignition, yeah.
for a street engine, you want a hot plug. I mean, you'd think you want a hot plug for a racing engine, but it isn't. You want a hot plug for a grocery getter so that the heat takes a long time to get out of there. The plug stays warm while you're sitting at a traffic light so that it doesn't foul out. You can drive away. But I used to have people come in and they'd say, well, I hear you're really good at carburetors and distributor recurbing and tuning and stuff like that. I got a street car I built, and I got a 12-to-1 motor in it, and I need to get it tuned. And I said, well, you're going to have to find somebody else because I can't tune it. There's no way I can tune it for the street. If you want to make it a purely race car that you tow to the track, I can tune it for you. But don't come to me with a 12 or 12.5-to-1 motor and say you want to tune it for the street, because you aren't going to do it. The only way I can tune it for the street is detune it. You're probably going to lose 50 to 75 horsepower. And you would have made more than that if you built it at 10-to-1.
Now, see, here's what I don't understand. My Cougar, I mean, it's like 13.3-to-1.
Yeah.
Okay. Makes 750 something horsepower. Well, it makes more than that now.
Mm-hmm.
I run an Autolite 39-32. And then sometimes I run a 33. I don't even know much difference between the two. I put them in there.
I don't even know where those are.
I just freaking go. And I drive that thing on the street. The key is a carburetor. I mean, at least to me, it never fogs up. It never loads up. It just runs good on the street, whether it's on the street or track, the same.
But what goes on there is you're running richer jet than you need to be, because you're having to put more fuel in to help keep it cool. The other thing is, on the street, you aren't running any vacuum advance. You're driving part throttle. You aren't running any vacuum advance.
Yeah,
so the timing is
locked anyway. Yeah.
Your timing is way retarded from where it needs to be. Most people don't realize when you're out on the street, like a street car. I had a 72 Cutlass. Most people don't realize part throttle, that thing ran 54 degrees advanced. I had the thing set up for 54 degrees advanced. People think that part throttle, you run less advanced than full throttle. No, it's the opposite way. Full throttle, you run less advanced,
right?
Because you've got a dense mixture that burns fast. Air fuel ratios burn at different rates. For racing, we run an air fuel ratio of about 12.7-to-1, because that's what burns the air at the fastest rate that gives us the fastest pressurized in the cylinder to push the piston down. But it doesn't burn all the fuel. It doesn't even come close. As you go leaner from 12.7-to-1, as you start going on out, the flame speed gets slower and slower and slower and slower. It doesn't burn as fast. So you have to have more advance so that the peak pressure comes just after top dead center. And so if you take a look at, get an old motors repair manual or something like that, and look up they used to put the distributor curves in there, where the mechanical advance started, when it all came in, and then they had vacuum. If you put a vacuum gauge on your engine and you have an RPM, a tachometer, you can see, I'm going down the highway here with my gearing. I'm at 2,700 RPM. So there I got 28 degrees in the distributor, and I got 10 initial. So I got 38 mechanical and the initial, but I've got another 12 degrees on the vacuum. So that puts me at 50 degrees. I mean, people didn't realize how much advance you got when you're running on the street. You're losing 5 to 6 miles a gallon. I know you don't give a damn about, but you're losing 5 to 6 miles a gallon because you don't have any vacuum advance. I was just at a street cruise here in Daytona Beach the other day on Saturday. I was walking through there and I'm looking at all these cars, and very few of them had an original distributor, and they all had MSD distributors or something, and none of them had vacuum advance. And I'd talk with them. Everybody had the same complaint. Well, they heat up a lot. But it's Florida. They didn't heat up back in the day. There was no problem. The reason they heating up. I didn't tell the people this. I wasn't going to insult them.
Right.
They didn't have vacuum advance. I mean, when you don't have vacuum advance, your burn is actually taking place late. It's retarded under a part throttle condition, because you've got a leaner mixture you're driving. It's slightly leaner than full throttle, even with a racing carburetor, hopefully. And so your peak power is coming with the piston, really going down the hole a good ways. And that just exposes the cylinder wall to that heat, and that makes the coolant get hotter, okay? And so the engine runs hotter. If you want the engine to run cool, you got to have vacuum advance. Another thing with Fords and Chryslers that people aren't aware of, I ran into a lot of problems with Ford and Chrysler distributors, and it didn't matter whose distributor it was. The problem with Ford and Chrysler is they all have one bearing in them, and then the bottom of the shaft locates in a hole in the block, okay, where the oil pump drive comes up, but it's there. And of course, even though you have a thrust plate on the camshaft, that camshaft's walking back and forth as you load and unload that engine. That thing's moving back and forth, and it's side loading that shaft, and it's wearing that bearing. And as that bearing wears, you start getting spark scatter. Okay, I had a distributor machine. I didn't realize this at first. I was recurving distributors. I learned about distributors when I was working at Holley. People didn't realize Holley was the third largest manufacturer of ignition parts. They invented the Chrysler electronic ignition. They sold the whole deal to Chrysler so that they could have the carburetor business. But Holley invented that ignition, which was basically copied by Ford. But those distributors, a Chevrolet or GMs, they all have two bearings in the distributor. One at the top, one at the bottom, stabilizes the distributor shaft, but not Ford and Chevy or Chrysler and Mopar. And so as the cam's walking back and forth, it side loads that shaft. That gives you all sorts of spark scatter, so you're getting unequal spark timing at the various cylinders. When I first started recurving distributors, the Sun distributor machine used a mechanism, and it was triggered by the points on the distributor. And you could tell what the accuracy of the, you could see when each cylinder was firing, and you could see wobble would show up a little bit in there. And a new distributor would be fine. After it had some age, you'd see variation in the spark. And people attributed that to heavy duty contact points. If you were running racing points, the spring was so strong, it would wear out the bearing and stuff like that. They threw that all out. Well, that was all BS. It was due to the thrust of the camshaft on the gear. And even though the Chrysler gears held in place in the block, Ford's isn't. But I mean, you still had a thrust factor there that affected all that. So when electronic ignitions came out, everything's good. Everything's good. And I thought, wow, electronic ignitions really are good and accurate. Well, what it was, to run an electronic distributor on a Sun distributor machine, you had an adapter. The adapter was averaging all the air together, so you didn't know that there was a problem. I didn't find that out till about 10 years later when my distributor machine wore out. And I called up Sun to buy a new one. And this was like in the late 80s. And, computerized ignitions were coming about. They aren't going to make any more distributor machines. They had made 60 special electronic distributor machines. They had 2 left. I bought the last 2. I still have one in my garage. But I got it in. I started putting Ford and Chevy distributors on it. Whoa, spark scatter everywhere. And with a gasoline engine, you've got an optimum point where your power is, and you got about plus or minus 1 degree at any given RPM and load. You got about 1 degree variance, plus or minus, say a 2 degree range, where your spark has to be accurate. Alcohol, it's plus or minus 4 or 5 degrees. Nitromethane, plus or minus 12. It's
forgiving.
It's like playing with hand grenades with nitromethane. But with gasoline, you got to be accurate. Well, all of a sudden, I started finding, I couldn't find a decent Ford or Chrysler distributor at all, especially Ford, because Chrysler at least had the gear anchored in the block. Ford had the gear on the shaft, and it's the camshaft's walking back and forth. And boy, did that work. I never found a Ford distributor. I don't care if it was OEM Ford, if it was Excel, Mallory, MSD, 20, 25,000 miles on them, they were shot. Okay. I got with a rebuilder company called A1 Cardone out of Philadelphia.
Yep, I've heard of them.
And I started sending back a bunch of rebuilt distributors. I couldn't find distributors that had vacuum advance for use on the street, so I was using these factory rebuilt. I sent so many of their distributors back as junk that the vice president of the company came into my shop and says, "We want your business, but we can't afford to do business with you because you're sending all these back as defective." So took him back on my machine, and he had never seen anything like that. And he says, "Oh my God, we got a problem." And they actually made an effort to tighten up all the tolerances in the bearings so that the distributors were accurate. But what you really have to do this goes to about when you're building an engine, you control that end thrust with where the cam plug is in the back of the block. So you got to put a dial indicator on a Ford or Chrysler. Chevrolet didn't have a thrust plate. I still would work with it. The timing chain basically took care of it in the Chevy, but you really didn't have to worry about it because you had two bearings at the distributor. But you really have to set up an end play on your camshaft of about 3 to 5 thousandths. 5 thousandths max. Usually you could run maybe two minimum, but I like to run 3 to 5 thousandths on the end play of the camshaft, and then it isn't going to affect the distributors much. That's another thing where the accuracy of the timing. You really want to run. You got to run a timing chain. Guys want to run gear drives, and all a gear drive did was take all the torsional twist on the crankshaft and take it right up to the camshaft and shake the whole distributor apart. We did a bunch of tests on gear drives when I was at Crane, and a gear drive cost you 17 horsepower on average compared to a timing chain.
Man, but they sure sounded good on the street. I used to run one.
They sounded good for about 3 days. Then when you couldn't hear the radio, you wanted
to. I used to love that. I got the noisy one, Pete Jackson out of Cleveland, and it was actually my first motor. Man, I love driving around my little town with that thing.
Yeah.
Let's see. There's some questions here. I saw someone talking about. Let's see. It's good to see you guys. Dave Cavender, Don and Natalie, and Lucas Heimberger. Good to see you guys. Michael Caruso. Let's see. I've always had bad luck with A1 Cardone because when I used to wrench, I remember A1 Cardone was one of the reman guys that were just coming out. So that had to be the 80s.
There was a period there where they, and all I'm talking about is the distributors. Okay.
Right.
Like Ford distributors. There was a bunch of stuff there that I agree with them. All those manufacturers,
alternators, calipers were having problems. I remember back in the day.
Well, alternators, the big joke there is you got 3 phases. So if it's a 60 amp alternator, you had 20 amps per phase. As long as you had 2 phases working, it'd charge the engine and everything else. So you could have a remanufactured alternator that only had 2 phases, not 3 phases working, and the customer didn't know it.
Now, here's an interesting one. That's why Ford used an oiler tube with a spring-loaded cap on some of their 427.
Yeah.
I've seen those caps. I know what you mean, John. Yeah. Let's see. What's this say? Gear drive keeps your valves flying. That's funny. But someone asked, another guy here who asked a question, which I'll kind of give my 2 cents. Let me see if I can find it again. But he was talking about a motor that he built, and it's in a Falcon. Let me see if I can find it again. And it's the hard thing when I'm looking at this stuff, I forget when we're talking about stuff. But you always think that a bigger bore is always better than a longer stroke. Do you believe that?
A bigger bore does so many things for you. First of all, it increases your cubic inches, but
Sure.
It allows you to put bigger valves in the head, and it unshrouds the valves.
Yep.
And so all sorts of good, long strokes, the best way I explain things is when I was teaching at college, I'd talk about to a kid, imagine running down the hallway, and instead of walking straight down, you're running against the wall. If you're just pushing lightly against the wall, like you would with a long rod, there's not that much friction. But if you're really pushing into the wall, like you are with a short connecting rod, there's loads of friction. And internal friction due to the rod stroke ratio increases with the square of engine speed. So whatever friction you have at 2,000 RPM, 6,000 RPM is 3 times as much. Well, that's 3 squared. So you got 9 times the friction at 6,000 that you do at 3. Put it at 8. That's 4 times as much. 4 squared, 16. You got 16 times as much internal friction at 8,000 RPM as you have at 2,000. So you want to minimize that internal friction as much as you can.
He asked this question here. I'll just kind of make a comment on it. I made 716 horsepower, 592 with a 13-to-1 Trick Flow Specialties 225 R Series head, 430 cubic inch Windsor, cam specs 271, 281 at 50, 724, 724, and a 110. Does this seem optimal? No. That motor should be making more. That motor right there, those heads, that cubic inch, that should be making about 780. So when I look at those cam specs, there's not enough lift in that cam. You know, that thing needs a lot
Right.
more.
No, and even duration. I mean, your duration could be a good bit more and everything else.
Sure.
I mean,
those things are flowing pretty well, like in the I want to say 370 range or something.
I mean, it comes down. I always said it comes down to horsepower per cubic inch. You know,
Yeah.
One of the problems you get when you go to these big engines is, unless you have a special block, you know, you can't get a good rod stroke ratio. You're better off to turbocharge it and keep the engine RPM down than try to turn it high RPM, because all you're doing is beating the hell out of the block and the rods and the bearings and everything. And so you want to, with cams and heads that are out there, well, I told you that mule engine, 10-to-1 motor, 355 inches, and we made 486 to 490 regular. I mean, we could put different cams and stuff and get up into the 512, 515 range, but 486 with a hydraulic roller cam was nothing, you know, and it was very tunable. You could put in a car and just drive it and be no issue. So you ought to be able to make 1.4, 1.5 horsepower minimum per cubic inch without too much trouble looking for a performance engine. And, you know, for circle track racing and stuff like that, you better be up there close to two horsepower per cubic inch.
What am I think I'm making 1.9 right now.
Mm-hmm.
You know, with 50-year-old parts. Let's see. And this is a good point too. You may have looked at things this way. Hot rodders have become one with the race motor. You have to morph into a race engine to learn its needs and its hunger. Dynos are a tool. Treadmills are used to determine person's cardio. So it's a good point. I mean, you got to know what your car wants, and you get it by testing it, whether it's a dyno to get things to make sure it don't blow up when you put it in the car to race it, and then track time, seat time, man, and see what you got.
Well, one of the concepts for any kind of tuning, I mean, is that you got to understand the flame speed and the optimization of flame speed. If you're into a and right out of the box at Holley, when we developed the carburetors at Holley, we developed them, and gasoline was a lot better at that time.
Yeah.
We developed them on gasoline. It was about a 75.75 specific gravity. Okay.
Yep.
And we always jetted them so that they would be probably about 2 jet sizes rich, just to make them idiot proof. Okay.
Yeah.
Okay. So, because you can never hurt an engine if you're a little bit rich.
Right.
You can, it's like a torch, a acetylene torch. When you want to cut something, you add the oxygen, you make it lean.
Right.
And I get in here, different flame, if you're running, it comes out of the box, let's say you got a 750 double pump or something that has 75 main jets in it. I forget what it is, but that's in the ballpark. Let's say for whatever reason you find you have to be up at 79. Okay, something's wrong there. Because really, we were about 2 jet sizes too rich. It probably ought to be 73, 74. If you're up at 79, that's telling me you got too hot of a spark plug in there. And you're using fuel to cool the cylinder down.
Okay.
So you need to be, you need to look at going to a colder plug so that you can back the jetting down. And you can't believe how the power will come up when you do that. I mean, people don't understand how much power is lost, because as soon as you start putting extra fuel in to get the plug to color up, everybody says it's supposed to look like light tan. Well, if you got too hot a plug in there, you got to have extra fuel to make it look like tan, and you're fooling yourself. That's where you got to use the reference of what was in the damn carburetor when I took it out of the box, and about a 12.7 to it's on page 2 there, about 12.7 to 12.4 to 1 air fuel ratio. That's about where you're going to be. If your power is pretty much stable in that air fuel ratio range, But when the air-fuel ratio gets leaner than that, it burns more slowly, you lose power. When it gets richer than that, it burns more slowly, you lose power.
Right.
Okay. So a lot of people think that all air-fuel ratios burn at one speed. They don't. There's vast differences in air-fuel ratios, and that's what one of the things they need to know. And one of the things when you're tuning, I put in there, discuss the burning leaves metaphor. My burning leaves metaphor is this.
All right.
Hi.
All right, guys.
You're too cute. Hi.
All right.
Hi.
Here comes my awesome wife,
And
Andrea.
And Zeus, doggy.
Hi.
Mom, pick up Zeus. I couldn't come for me.
All right, relax.
All
now.
right. Yeah, we're just.
So Juicy
We
Man.
have our dog.
So
Juicy.
Juicy Man.
No, that's okay. We can't right now. You're too high. So.
I got my dogs in the other room. I have 2 dogs.
Oh, do you?
Yeah.
It's our first dog. He's a character, man. We love him.
I got a yellow lab and then a combination of a lab, he's lab and chow and shepherd and some other stuff.
Oh, wow.
Relax.
Nice.
We got a little Doberman. Well, he's 4 months, right?
5.
5 months, and he's like 50 pounds. So.
He ought to be losing his baby teeth pretty
You know
soon.
what? I think that's what.
Six
Yep.
months. Yeah.
Yep. They're falling out. I can't
Yeah.
wait for him to be gone too.
Yeah. Oh, he'll be proud of having the new teeth. I mean, he'll be showing them to you.
Relax. Okay, guys.
All right. Well, let's go.
Well, we're only going to be talking till probably about 9, and then we're going to be calling it quits. So,
I love you, Daddy.
All right.
but hey, thanks guys for
Just wanna-
saying hi to my girls.
We got ice cream.
Okay.
Will
All
not
right.
come. Bye.
Bye.
What is this oil for again?
It's just oil I like to have in that container to look at later.
They're cute.
Thank you.
Okay, getting back to my
See you.
Bye, Daddy.
Love you. Bye.
Bye.
Bye. Okay. All right.
getting back to my burning leaves metaphor.
Are you Daddy?
All right. Bye, guys. And so what you're saying is different air fuel ratios burn at a different speed. Now,
Yeah.
are you talking about the flame front?
Yes.
Okay.
And burning all the fuel. You know,
Right.
you hear all these people say, "Oh, to make most power, you got to burn all the fuel." That's total BS. Because different air fuel ratios burn at different rates. So you've
Okay.
got to burn you burn an air fuel ratio that gives you the quickest pressurized. We don't give a damn about burning all the fuel. Okay, this goes to the burning leaves metaphor.
Okay.
If you ever rake leaves in the fall and then burn them.
Yep.
Okay, get them in a pile. They're nice and dry. You throw a match on them. And if you stand back, that flame burns up pretty good and gets so hot you got to back off or your eyebrows are burning.
Sure.
Right? And that's a quick, rapid burn and a quick pressurized. But what happens when it all burns down? You take a rake and you go back underneath. There's all sorts of unburned leaves. If you want to burn all the leaves, you throw the match on there, you let the flame come up a little bit, then you take the rake and you put some leaves over the fire. And let it burn a little bit more. And then you take some more and burn it over. And it takes time to burn all the leaves. It is a slow burn rate to burn all the leaves. It is a slow burn rate to burn all the fuel. So way back in the 70s, before catalytic converters, the air fuel mixtures were extremely lean, and with retarded spark timing, and the burn rate was very slow, and that's why none of those engines made power. You could have taken any of those engines. When I worked at Banks, we took a 75 454, okay, put it on the dyno, made 195 horsepower.
Yeah.
Okay, but change the cam, heads, because the 75 oval ports were terrible, but put like a 71 oval port on it, and a nice tunnel ram made for the oval port heads, and just something as simple as an L88 cam. You were at 515 horsepower.
Wow.
On an 8-to-1 motor, 8-to-1. So, I mean, and an L88 cam wasn't optimum for something like that. You know, you would use something different. But what I'm getting at is the concept of flame speed is critical. And the flame speed's got to be matched to the spark plug heat range you want to maximize the heat on the piston, and that heat's got to come out of that spark plug in such a way that it stays in its operating range. And that's all determined by the compression ratio you decide to work with. Aluminum heads you can run about on a street, you can run about half, or even on a racetrack. I mean, you can run about a half to 1 point of compression higher with an aluminum head because it transfers heat to the water jacket so much.
Now, I never knew this, but here's a quick one from Adrian from New Zealand. Latest factory Mustangs are 12-1. I never knew that.
Well, you can do that. You know, you can do that
obviously. You
can do it with a lot of cars now because for a couple different reasons. You got aluminum heads, so that helps dissipate things. But you got a detonation sensor. You got a knock sensor.
Sure,
so
sure.
Then, you know, you can. It's a premium fuel motor. You aren't doing it, but you could run. You could run 87 on because the detonation sensor will back the timing so far off that your ignition's starting off when the piston's going down a hole. So even though it says it's 12-1, effectively they're running maybe 10.5-1 by the time the pressure peaks.
Okay. You know, what's funny is top fuel cars start off with on 87 pumped gas before they go to nitromethane.
Mm-hmm.
Here's one. Is there a correlation or guideline with static compression ratio to desired water temps? Or is it not pertinent because of effective compression ratio taking place running half to full wide open?
That's it. It's not pertinent because of your effective compression ratio.
Okay.
You know, like I said, if you take a look, it's interesting that a lot of the car manufacturers, if you really take a look at buy an aftermarket temperature gauge and put it in a modern engine, lots of times it's going to read considerably higher than what the gauge of the car does, because they don't want you knowing how hot they're running the car.
Okay.
Okay. They run them hot.
I mean, do you really think they do that though? The gauges are not the same as an aftermarket. You think they're like factored a little bit different so they don't look?
Oh, yeah, it's easy enough to do. That's not.
Yeah.
Another thing, I threw it in there. You know, if you want to learn a lot about engines, a good place to learn about engines is the Society of Automotive Engineers. You can go to the Society of Automotive Engineers, and you can buy the engineering papers on all these engines, you know, when they were developed. One of the interesting things that I learned off of that is if you take a big block Chevrolet and just the way the water jacket's made for the water to go down around the spark plug to cool the plug off and the exhaust valve and everything.
Yep.
I think it's on the, if it's sitting on the passenger side, the flow through at the normal water pump speed, you know, say engine's running 2,000 RPM or 2,500 RPM, that water pump will pump 60 gallons a minute through that head. You take that head, put it on the other side, only will flow 40 gallons a minute, because the angle of the deflectors in the casting slows the water down that much.
Wow.
I never really ran into it until I was working at Banks's, and we would put a temperature gauge in each head. One head was always running 20 to 30 degrees cooler than the other, just because of the water flow rate through the head.
Yeah, here's a good one that explains that.
Absolutely. Absolutely. You want to run that thing warm. You know, heat is power. I mean, it's simple physics.
There you go. Vacuum Advance gives greater throttle response at part throttle.
Yeah, I used Vacuum Advance on our circle track cars. People told me I was nuts. Okay. And what I did is I limited the Vacuum Advance. Morosa made little things that you could limit the Vacuum Advance. I always used the GM-HEI. GM-HEI for a Chevrolet, just a fantastic distributor. You cannot buy a better distributor than a GM-HEI. You can buy as good as, but you aren't going to get any better because they're just dead nuts accurate.
Okay.
And I would put a Vacuum Advance canister on there, and I would. Can I help you?
No, not now.
I would put a Vacuum Advance canister on the distributor so that when we were going into the turn, as the driver let off the gas a little bit, it would add just a little bit more advance into it to help, because you've got high vacuum then, lots of fuel coming out of the idle circuit, not a whole lot of air. So your air mixture is going really rich. So I wanted more time to burn that extra fuel off going into the turn. So we kept the plugs clean. So when you come out, you nail it and you go. And You know, people used to laugh at me. I didn't give a damn. We were winning. They weren't.
Thank you, Don, Natalie, Lucas, Heimbigner. Thank you, guys. That makes me, that's DragBoss Daddy. Yep. The kids want to come out here and fool around and be on the video, and we'll have to make our own video. They have a whole bunch of parts I still haven't opened up from weeks ago, so they want to make a video tomorrow. I said, all right, you guys can make your own video. And they were talking about this oil. Back in the day, I used to send my oil to get analyzed and have them run whatever they do, and it tells you how many parts per million of zinc and everything that's in it, and the tin for the bearings and all that stuff. And Kendall used to do it way back in the day. So I was going to see if I could send some oil to get it evaluated at one time, but then I kind of like, you know.
Well, that's, you know, Brad Penn is the old Kendall.
Right. Yep. There it is.
People aren't aware of that. Yeah, Brad Penn's the old Kendall.
So thanks, John Elliott. Appreciate you being here. Dr. Ron Burgess. We need any psychiatric help, he's here. He's a psychiatrist. So he's a big drag racer, has quite a few cars. I've put his cars on here before. Lumbee Warrior to see the DragBoss Garage video on my 830. Yep. 830 cubic inch or 830 horsepower Boss 302 with iron Boss 302 heads, 3-inch stroke, 400 rod, super stock legal.
Yeah.
So
that's the way you do it. That's the way you do it. Yeah.
Sun. I remember the old Sun distributor machines, like you were saying. They were gray and red, I think they had enameled.
Yeah, but see, the most of them were designed for a point type ignition. When they went to electronic, they had this adapter, and it averaged everything out, and you couldn't find. It was like all electronic distributors were good. The point type distributor, if you ran them, it would show up your spark scatter, you know, and you knew you had a bad distributor. But then you put the electronic on, and everybody chalked it up to, well, it's not seeing wear from the points. It was a bunch of bull.
Wow, here's one for you. I don't even know what he's talking. I don't know this one. What do you think of the Braswell B7395 Pro Stock 4V carbs for dual quads with 4 and 5 circuit replaceable air bleeds? Have you ever had any knowledge with these particular carbs?
I don't have any knowledge of them. I told you the other day, the last time I was on, I had the best airbox in the world to work with.
Yep, I remember you told me.
I saw one of your guys said something about a Superflow. Well, Superflow, I mean, this airbox was built in 1940. I mean, for B29 carburetors, you know, it was huge. But when you work out the air bleeds, that is a volume thing. And I would never mess with air bleeds, ever. I wouldn't mess with air bleeds on any carburetor I designed that I had flowed on a flow box. There's no way in hell I would ever mess with air bleeds because they have such a minute effect. Your air fuel ratio and the fuel weighs so much more. You do so much more with the fuel than you do with the air bleeds. If you're messing with air bleeds, you're just. I've got a lot of experience with these things. Yeah. I have no idea what I would do. I would just leave them alone. Whatever was on, you know, came out of the box. Dave Braswell is a pretty smart guy. I told you that the last time. I don't know who's doing the stuff there now or how much he taught him or anything like that. So I can't make any comment one way or another.
I'll tell you, I like the way they look on the carburetor, all that fancy stuff that you said doesn't work, but I like the way it looks. That's
yeah, I mean, that's fine. You know, I like the way a lot of stuff like that looks too. I can appreciate it.
As an aside, you told me that you actually, when you worked with Holley, you would actually have to go to look at carburetors or evaluate them from racers that had died in accidents.
Or badly injured. What usually was the ones that were badly injured, crippled and stuff.
Okay. Where you evaluated the carburetor and said, okay, this is one of these aftermarket carburetors where they thin the.
No, not an aftermarket. It was a Holley. These were Holley carburetors.
Okay.
They weren't aftermarkets that people, the aftermarket carburetor business wasn't even there. Okay. These were Holleys, but people had modified them.
Okay.
And made them unsafe. They'd thinned up the throttle shafts and stuff like this to the point where the throttle shafts broke due to high vacuum. You know, they kept flexing and flexing and brake, and the throttles would jam. And then here you go, you're at the end of the straight, and you're trying to back off, and you can't, and you go up over the fence and out and roll in a few things, and people would be, crippled.
Here's one, if you can remember this. Let's see. The only thing I remember the difference between the Scorpion and the Torquer is that the Scorpion has like an extra, maybe a half-inch plate, a spacer incorporated into the intake. That's all I know.
Well, the Scorpion had an air gap. Torquers all had an exhaust heat crossover.
Okay.
Went under the carburetor. The Scorpions had an air gap to help keep the charge cool. Supposedly the Scorpions were, had bigger runners, but I told you the last time, they went and they put a Venturi in the runner thinking they was going to speed up the airflow right before it went into the port to help the turn. All that did was kill horsepower. Waddell Wilson used to take those things and weld them up and really increase the volume. He'd just grind out that whole Venturi that they had put in there, and it just gave them a lot of aluminum to work with that he could open up the ports. But a Scorpion can't hold a candle to any of the good. A modified Scorpion possibly could, but there's so many good manifolds out there today. A regular out-of-the-box Scorpion couldn't cut it in today's competition.
This is from Michael Caruso. Coolant flow is so important, being equal, as they never are great tip, Mark. In 1990, did a lot of water pump, water flow, and impeller studies at Feldpro.
Yeah, you want to equalize it. See, that's the other issue I have. A lot of guys, and this isn't anything against aftermarket heads, but the OEMs really spend an awful lot of time on the water flow through the head, through the casting, and the deflectors they have in the casting, and all the other stuff, and to get uniform temperature throughout the head. And I don't know that aftermarket guy, for drag racing and stuff and an aftermarket aluminum head, let's face it, a lot of fuel stuff and everything, those were solid billet heads. They didn't even worry about any water jacketing. But some of the aftermarket heads are out on out for the street, like particularly in aluminum or something.
Yeah,
I don't know. I don't know how reliable they are with respect to how even the combustion chambers are in temperature, and that all affects power, and it affects fuel economy. We were talking about the jetting, or I don't know if you want to go over about the specific gravity at all. I put an example in there about on page 6 about if you go from the carburetors are developed with a specific gravity of 0.75, but this is at the top of page 6.
Yeah, I see it here.
But most of your racing fuels, VPs and stuff like that, they have a specific gravity of about 0.71. So the difference between 0.75 and 0.71 is 0.04, which is a 6% change. Okay. It's a 6% change. Yep. So what you got to do, you got to increase, because the fuel is lighter, you got to increase the amount of fuel by 6%.
By jet size. Yep.
So, and you got to do that by area. So if the thing had 72 jets to begin with, the diameter of a 72 Holley jet is about 0.79, which if you go to an area chart, transfers out to 0.004870. If you increase that by 6%, you come out to 0.0051622 square inches, and that equals a diameter of 81, which corresponds to a 74 jet. So you'd have to go up 2 jet sizes running VP fuel compared to a fuel that was 75.
I would have to take it to the track and just jet up and see if I go faster, because that math is just too much for me.
We had a situation years ago at track. We were running the big 2 barrels, the 650s.
Oh yeah, yeah.
And I told you about the restrictions that were in the metering box and everything.
Right. Yep.
And we used to run Cam 2 fuel. They'd have Cam 2 at the racetrack. Well, this one night we got out there and we bought fuel and went out, and the car's out there, bah, 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 bah. And everybody's out there, bah, 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 bah. And I smelled. I finally realized it was aviation gas.
runs hotter.
Well, you got all sorts of issues with it because it vaporizes faster and a lot of other things. So I took the jets out of the carburetor, ran the carburetor without jets, and we won the feature. And well, you had to have so much bigger jets. The avgas was so light.
Right.
You know, and we were already running like a 90 jet in the damn thing because of certain issues. And so I just took the jets out. And about 5 guys burned holes in their pistons that night on that we were racing with. We ended up winning the race. We loaded the plugs up pretty good, but we won. And you aren't going to hurt an engine if you load the plugs a little bit. But it was because and the company that delivered the fuel, they ended up getting sued because they were passing it off as CAM 2 and it was avgas. People took some samples, had it tested.
Someone asked me about, let me see if I can put it up here. And what I'll do is I'll make a video and take pictures of these and incorporate a video of this because there's so much extensive knowledge in here. I started reading it. It's like you got to sit and read it a couple times sometimes to get in my thick skull. So I'll share it with people. You said you didn't mind, right, Mark?
Well, you use it however you want. If you want to, you can post it someplace where they can download it or whatever you want. I don't care. You know, another thing we want to talk about is adjusting the mixture screws on the carburetor. And I'm shooting for 20 miles per gallon on 2 Dominators on. Well, that's for sure.
He's already done 16 with it, and he's just put some new carburetors or messed around with them. He's got a new motor, 429 cubic inch, small block Ford, but with like Boss 429 style heads on it, on a small block Ford. It made 720 something horsepower, 717 or something.
Key is vacuum advance. That's absolutely true.
That's
People don't understand how much advance you have to have there. I got sued years ago when I worked at Holley and several other people. What happened with, I don't know if you knew Tim Cook. He was a writer for
Hot Rod.
Yeah, he wrote for Hot Rod and Carcraft and stuff like this. And then in the first energy crisis, he said to me one time, he says, could a guy with because he had it was his vehicle. He said, could a guy with a 360 Chrysler get 20 miles of the gallon out of a Dodge van, or a 360 Mopar in a Dodge van could get 20 miles of the gallon? And I said, sure. And he said, well, what would you need? And I said, get yourself a good RV cam and get the distributor set up right. And we had what we called the emissions performance, or the RV carburetors that were the predecessors of what was called the Holley Economasters.
Yes.
And they were designed for towing and things like that. And so he did a whole article on this, and I explained what needed to be done with the distributor, about it really needed vacuum advance and how you could adjust it. See, Chrysler and Ford, in their vacuum advance canisters, if you take an Allen wrench, you can go right in the nipple of the vacuum advance canister, and you can adjust the amount of vacuum advance or the rate of it. I think Chrysler, you adjust the amount, and Ford, you can adjust the rate, the preload on the spring. But anyway, so this guy bought all this stuff, and he didn't get it. He was getting like 12, 13 miles a gallon. He said this was all farce. And so he sued us. He went to the California Air Resources Board and said, we're, putting out all this bad information and that we need to be taken to court and all this stuff. So SEMA, it went to SEMA, and SEMA came to us and said, what's going on? Look this all over. And the whole thing was he had put a Mallory distributor in the thing without any vacuum advance. He didn't even know what the advance curve was supposed to be like. And so I ended up on a trip out to California, went by, took a distributor with me, one that we had set up, a regular Mopar electronic distributor, put it in, set up the carburetor the way it needed to be, set the eye, he had the jetting all messed up, put it right back to where it was right out of the box. We told him to put a camshaft in that was like a 204, 214 at 50, like 420 on the intake, 440 on the exhaust. And the other aspect was he didn't have enough valve spring seat pressure. So we put in some different valve springs for him, so he had the right seat pressure for the camshaft. And he was able to get it. We were able to get 20 miles a gallon. We were able to pass California emissions test. And so, but it was a pain in the butt. That's another thing about tuning. And this is just for street performance or something. Anybody with a hydraulic camshaft,
Yep.
You got what's really important with hydraulic camshafts is valve spring seat pressure. And there's a balance of forces goes on there between your valve spring seat pressure and your oil pressure and the bleed down rate of the lifters. And people think that hydraulic lifters, you get anti-pump up lifters and they don't pump up. All hydraulic lifters pump up. They all pump up. It's the amount they pump up or don't pump up. And most flat tappet cams come with on the seat, about 80 pounds on the seat, 80 to 90 on the seat, and somewhere around 280 open for flat tappets. But if you take that 80, and Ford uses the most El Gippo valve springs from the factory, and all the 302s, 351 Windsors, the Clevelands, M's, they used El Gippo springs, and those suckers go away. And after a little bit of time, your seat pressure would be down around 60, 62 pounds. And what happens is in cold weather, you'd fire those damn things up and they'd stop. And it'd act like they had a choke problem all the time. Fired up, stop, till the engine got warmed up, and then okay. And people would want to have the carburetor adjusted to the choke. They're always playing around with the carburetor. It wasn't the carburetor. It's the valve springs, okay? When the engine's cold, the oil's thick, the oil pressure's high, right?
Yeah.
And you'd probably be about 80, 90 pounds of oil pressure on a cool morning. And so you got high oil pressure and you got 64 pounds of seat pressure. And the lifters are pumping up just from the oil pressure at idle. It's pushing up against it and the springs pushing down. You can't imagine how many cars I fixed because they came to me because I was a carburetor specialist. I'd tell them I can change it, but not by fixing the carburetor. Let me put different set of valve springs in the engine. I'd put a set of valve springs in and put them in at 110 on the seat.
Yep.
I'd select springs that were like 110 and say 280 open. What was going on? Start that sucker up. No stalling at all because it had enough seat pressure to bleed the oil pressure down in the lifter, have the plunger go down, make sure the valves were really seating. They were leaking at the valve. You had a vacuum leak at the valve. That's what it was because of oil pressure. And not only that, that was probably 3-4. It is a lot of mileage, 3-4 miles a gallon. Unbelievable.
Wow. I guess I see what you're saying, but I mean, I would never have thought that. You know what I mean? And I remember, you just got to warm it up because it's got the carburetors. It's got a choke that doesn't work good or whatever. That big block Chevy I told you that made 195, and then we got up to like 515. Yeah.
We got 85 horsepower on an engine just on the valve springs.
Wow.
Now 38 at the power peak, but 85, 500 RPM either side of the power peak, just with valve springs.
Wow. Here's another buddy. He said the same thing. Try to tell people's valve springs back then too. Yep. New springs fix the engine, leave the Holley alone.
That's absolutely right. There's that hydraulic relation, and that's why you always want to run a thinner oil. You don't want thick oil in that thing. You want thinner oil to let that plunger bleed down. Then you get into hydraulic rollers, and people start saying, "Well, you got to be careful of those hydraulic rollers. You'll collapse the lifter." We ran a big block Chevy. Crane had the marine business at Mercury, the inboard stuff. The big block Chevys. Okay, built the cams and everything else. We did the lifters for them, and we decided to run an endurance test to see how much load a hydraulic roller lifter could take. And we took a big ass cam. It was, not super big, but it was like a marine application. It was like 630 lift. And we set this thing up for about 280. This is on a Spintron, okay, not a dyno. We did all this on a Spintron. And we set it up like 280 on the seat and about 650, 660 open over the nose of the cam. And we ran that thing, and we ran it and ran it. We ran it for a couple weeks till we we wore the lobes out of the cam, but we never hurt the lifters. Never didn't collapse the lifter at all. It held up just fine. You can run loads of valve spring pressures on good hydraulic roller lifters.
Wow. You might know this one.
I'm not saying you need to.
Right.
I'm not saying you need to, but I'm just saying you can.
Right.
I worked with Ralph Johnson, who was Smokey's right-hand man, and that was all a scam. That was an effort to get a lot of money, get money support. I mean, funding for a bunch of stuff. That never happened.
There you go. You hear the truth from Mark. He knows. I love it.
Matter of fact, I'll tell you this, Ralph Johnson. I'll tell you how smart he was. This guy, he was one of the 12 people honored for being most influential in the development of the small block Chevy. But he and Smokey Unick designed an engine to take to Indianapolis. That was a pushrod motor, but it was a cam it was overhead cam, but it used a pushrod. Okay, pushrod was only this long.
Okay.
Inch and a half. Okay, but because you could run a bigger inch engine if it was a pushrod motor. They took the Chevrolet and the design to Chevrolet. Ralph had the drawings in his toolbox, everything laid out. He drew it all up. It ended up Chevy never wanted to go ahead with it. Then about 10 years later, that engine, all those prints ended up over to Ilmore in England, and that was the Mercedes V8 that won Indianapolis, the pushrod Mercedes V8. It was that engine, those prints and everything else. And I remember Chase Knight, he was one of the customer support people. He did a lot with the fuel crowd, top fuel crowd. And he came into Ralph's office one day and he said, Ralph, show this guy that short push rod for that engine that you designed for Chevrolet years ago. And Ralph pulled it out and he used a bunch of expletives describing the people at Ilmore that, copied their engine and his design and won Indy with it. And Chase says, I want you to meet one of the guys, one of those expletives from Ilmore. That was the guy he was showing the push rod to. But Ralph designed that engine. Ralph and Smokey together designed that engine.
Ralph, Smokey he's one smart guy,
Yeah.
And, but he's also a scammer at the same
Yeah,
time.
yeah. There was a lot of scam stuff going on to get funding because he was the first one that came out and said, you never race on your own money. And Roger Penske learned that, and Chip Ganassi and all these other guys. They never race on their own money. They race on other people's money.
Best damn little garage in town.
Yeah.
Let's see
There's a big condo there now.
I saw that. You email me, and my email's on my information site on my YouTube channel. It's thpa351@gmail. You email me, and I'll send you a copy of this. Let's see what else. Would you use oil restrictors? I don't think so.
No. Mm-mm.
I know that there's some different blocks, like the dark blocks want to have an oil restrictor somewhere, but that's
no.
That particular
hydraulic roller cam. No, you need all the oil you can get in there.
Let's see what else here. Let's see, my first 400 had valve spring issues after I put a high volume oil pump in the engine.
Right. Because high volume is also high pressure.
I don't know whose springs they were, or how many miles on them since I bought the pickup used. I always go with new springs. It's not worth it,
Yeah. And I always used to go usually at least 10 pounds more on the seat pressure than what was recommended because they would always wear a little bit after about 10
runs or so.
No, I'm talking about on the street. What am I thinking about? 10 days of driving and things like that. They would.
Well, the seats get sunk in the head a little bit more. Things stretch and move a little bit more.
Well, hopefully they don't get sunk.
Now, one guy asked me about gem fuel, and he had written me a letter on it. And we talked about it, and if you don't know anything about it, but it's a fuel that they make.
Toluene and a lot of other stuff like that.
Yeah, it's a big mixture of fuels.
I mean, if you really know what you're doing, you can probably do something like that. But I don't. I got other things to do. I mean, it'd be a nice project to learn about it, but I just have other things to do.
But have you ever had seen anybody run it, or do you know anything the experience with
No.
it? Okay.
No.
Let's see. I would like detailed stuff for that carb trick. What I think I'll do is I'll make a video with the carb trick, and I'll try to cut it out from what Mark's saying and put it in his part with him talking about it, and add the papers to it and make a quick video.
See, you know, we talked about drilling out those main wells and the angle wells and everything. What you end up with, what you're going to see when you're all done with that, if you got an engine on the dyno and you do that, if you do it before and after, what's going to happen is the whole brake-specific fuel consumption curve is going to get flat. Your normal brake-specific fuel consumption is a little rich at the lower speeds. It's always the lowest at peak torque. Your brake-specific fuel consumption is always the lowest at peak torque, and then it rises up. But the real kicker where you make the power is keep that thing from rising up at the higher RPMs after your peak torque point. And so what that does, that just flattens out that whole brake-specific curve and really allows the engine to make good, keeps that air fuel ratio constant.
Okay.
On out at the top end. Carburetors naturally want to go rich. A lot of people think that a carburetor at high airflow goes lean. It doesn't. A carburetor will go, as the airflow increases, the carburetor gets richer and richer and richer. Okay. So, yeah, it's part of Venturi's principle. And there's the vacuum signal at the Venturi increases faster than the airflow increases.
What do you think about these lifters?
They're fine.
Rhodes lifters.
Yeah, they're made by they're made up in Cleveland.
Are they? I don't even know
what they were. I mean, what Rhodes lifters were was they were lifters that had too much clearance between the plunger and the body of the lifter.
Okay.
If you take a hydraulic lifter apart and you take the plunger out and you put it in your pocket for 20 minutes and you go to put it back in, it won't go in because your body heat in 20 minutes will heat that up enough that it'll take up the clearance.
Okay. Yep.
Okay. And what they do, they hone the lifter body. I mean, it's done, most of that stuff's done very precisely where the lifter body's honed, they clean it out, and then they fit the plunger to it and everything else. What a Rhodes lifter is, it's a lifter that has too much clearance in it. Okay. Right. So it's technically it's out of spec for whoever's selling the lifter. It's out of spec, but that just makes it bleed down a little bit more. But you got oil pressure pushing the plunger up, and so that a Rhodes lifter will make up for some weak valve springs. But I'd still run good valve springs with them. But there's nothing wrong with them.
Okay. Now, I don't know much about Oldsmobile. Wild Rose Garage says they like oil restriction, pipe cleaners in the push tubes to restrict it.
Yeah, I ran Oldsmobiles for a long time. I mean, I drove Oldsmobiles because Oldsmobiles got you the best fuel economy. The reason Oldsmobiles got you better fuel economy than anybody else, like in a 350 size, take all the GM 350 engines. The Olds was a 4.057 bore with a 3.38-inch stroke, but it had a really long connecting rod. So it had the best rod to stroke ratio of any engine General Motors had. And therefore your side loading was minimized. So your internal friction was down. That helps fuel economy. The other thing they had a lot of nickel and tin in the block. Block is incredibly hard. You get 100,000 miles on a Chevy 350 and it's lucky to clean up. Usually it won't clean up with a 20,000th overboard. You have to go 40 or 30 over at 100,000 miles. 100,000 miles on 350 Olds is nothing. I mean, it's hard to even measure the taper. They just don't wear, okay? But they got a lousy oiling system the way the pan is. They pump all the oil up the top, but they got very bad drain backs in the head. Once the oil gets to the head, it can't get back to the crankcase.
Right.
So, yeah, a lot of people would put pipe cleaners and stuff like that, or restrict the oil on an Oldsmobile, and that all made sense. I never bothered to do it because I wasn't going to turn them that RPM. But Oldsmobiles were one of the first favorites in jet boats when the jet boat craze started in the early 70s.
Yep, I remember that.
And Berkeley and Jacuzzi would buy Oldsmobile engines and use them in jet boats. And they had a lot of torque. And the kicker with a jet boat is the horsepower requirement of the impeller is exponential. For instance, if I remember right, it takes Takes like 290 horsepower to turn a impeller 4,800 RPM, and then it took like 400 horsepower to turn it 5,000 RPM, and then took like 650 to turn it 5,200. And you're climbing this greased wall. You know, it took like to go 5,500 RPM took like 950 horsepower. The requirement on the pump was just exponential, which is why turbocharged engines were great with that, because the boost would go up exponentially, so it was ideal. The problem with the Oldsmobile is they only have 4 bolts around each cylinder, and they've got little dinky head bolts, and you can't blow on a diesel. That's when they made that stupid diesel engine out of an Oldsmobile. That was ridiculous.
Oh yeah.
They didn't have enough grip strength out of the head bolts to hold the heads on the block.
Okay. Yeah, they're 22-to-1 compression too.
They turned the exhaust port down because it's molded into the head to clear the frame rails. When we were at Banks we were sponsored by Jacuzzi for the stock class of Jet Boat Nationals. We raised the exhaust ports an inch 100, raised them 1.100 inch, had them all furnace welded, raised them up. That was allowed in a stock class. Okay, that was 110 horsepower. 110 horsepower, raising those exhaust ports. Now, you could never fit them in a car, but in a boat, it was no problem.
How about this one?
Your maximum open pressure on a flat tappet cam that you want to run is 330 pounds. Okay, that's just the guideline due to the metallurgy of the casting. 330 is maximum. The cam 100 to 300, I'd run it in probably on a lighter spring. You know, I'd probably run it in on a lighter spring and then put those in. And is this a small block or big block? What size intake valve you looking at?
We'll see if he gets back to us on that.
And is it mechanical flat tappet or hydraulic flat tappet? That's the question.
Okay. You hear that, Michael? Let's see. He may have got back to us. Let's see. We'll keep going down and see. Keep getting questions about the Golden Moroso secret in the background. Keep getting questions about the golden.
The valve covers.
Oh, in the back, those, yeah, I got a couple motors back there.
Yeah.
I'm making a video on Pro Stock cams, and I got a subscriber, a buddy, kind of, now he's a buddy, but we kind of knew each other way back in the day from the old forum days in the 90s. He sent me a pallet from Montana with a XC Cleveland block with furnace brace cylinders, and then the high port Cleveland heads, which are sitting back on the workbench. Right there's one that had the exhaust ports cut off. You know what I'm talking about.
Mm-hmm.
So I'm making another video on it, and I'm going to build that motor.
It had the plate welded in and tacked and everything.
Yep. It's back there. I end up bringing it back here. I'll kill my back, lifted the damn thing awkwardly. Let's see what else we got here. So we're kind of caught up with questions, but
why don't we go over adjusting the mixture screws real quick?
Yeah, that's a good idea.
What we want when you set up the mixture screws on a carburetor, you want to keep that idle circuit clean. Like I told you, it's the most important circuit in the carburetor. So let's say you with the cam and everything, you're going to adjust this thing for around 1100 RPM.
Okay.
And you got a 4-barrel with 4 screws, 4-circuit idle circuit.
Yep.
And 4 screws. So what you want to do, you want to add 50 RPM for each screw. So you got 4 screws, that's going to be 200 RPM. So you're going to set this thing up for the most stable idle you can get at 1300 RPM. And you adjust the mixture screws in and out, out's rich usually, and you adjust them so this thing's as smooth as you can get it. Then and you want to do this while the engine's warm, after it's warmed up.
Sure. Okay?
Not cold, you want it warmed up. So then once you got it warmed up to whatever operating temperature you're going to have, you want to turn each mixture screw in and knock off 25 RPM as you lean out a mixture screw, 25 RPM. Then go to the other side, maybe diagonally, 25 on it, and back here, 25 on each one. So that's going to bring it down from 13 to 12. then go back through it another 25 on each screw, drop it down so you lose another 25 on each screw. That's 50 on each screw. That brings it down to 1100. It'll be a little shaky there. It's not going to be dead smooth. It'll be a little shaky, but it'll be super clean. You hit that throttle and it'll be super clean.
I remember, I think the biggest issue I've had with Holley Carbs is being too rich at idle. You know,
Well, that's where that leak occurred, that thermal leak.
Yep.
You have a Holley carburetor. If it's rich at idle, and you had it pretty well set, and then it gets rich, take a screwdriver and just snug up the 4 bowl screws on each end, just a little bit. If you can turn that bowl screw 1/4 of an inch on either end, it's going to make a huge difference.
No kidding.
Because the fuel's leaking through that accelerator pump passage in the metering block.
Okay.
This thing right there, that hole
Hold.
hole
Yep,
right there, that's the accelerator pump hole. Okay?
Sure.
That meets up with that hole right there.
Yep.
But you can see there's not much room for a gasket to seal there.
Right.
That's the longest distance. That's the longest distance from the 4 screws. That's the furthest away.
Okay.
And that passage is under the fuel level. The fuel level's right above here, right above where the top of that boss is, where the fuel level is.
Okay.
And you've got high vacuum in here. That's vacuum to activate the power valve. Okay. So that high vacuum at idle, that sucker's just sucking oil right past the power valve. And everybody thinks the power valve's leaking. Well, it isn't. All you got to do is snug up those 4 bowl screws. This is where Holley made a huge mistake back in about 92. They got rid of all the really good carburetors we had. Now, I told you, a guy called last week, or the last time we were on, asked about 4180.
Yeah.
4180 has a relief cut in here, and it's a bigger boss here, and a relief cut there. And there's a tube with 2 O-rings that goes in there, and it allows for all that thermal expansion and no leak. And we had probably 60% of the aftermarket carburetors we made. We had changed the castings so that they had that tube in there so that they wouldn't leak due to thermal expansion. Because you got steel bolts, you got zinc body or aluminum body, you got gasket material that all expands at different rates. Okay. And that would they would tend to leak there. But if you had that tube with the O-rings, never. They got rid of all those. You know, it was a cost reduction. The damn people had no idea why we did it. They got rid of it, and they kept all this universal crap that, excuse me, but they just aren't that good of a carburetor. You know, I mean, they're okay. And I don't want to insult anybody, but this is a fact of life. People talk about racing and making power and all this stuff and how smart and everything you got to be. It takes much, much more technological understanding to make a vehicle be able to start and drive in cold weather, hot weather, in town, out in the highway, up in the mountains. It's beyond making power. I mean, to make a race engine, making power is easy. There doesn't take a whole lot of expertise to make power. It's just pretty damn simple. If you focus on the basics there and realize the whole key is you want to turn the heat that's in that gasoline into heat on top of the piston. You want to minimize the heat going to the water jacket.
Yeah.
You know, that's thermal efficiency. Where we're really going to see power, where you're going to see a huge increase in power and fuel economy in the future is when ceramic pistons and ceramic coatings on the inside of the cylinder heads come around, where they will live. They're doing a lot of work on it right now, but they can only get about 100,000 miles out of those things right now, the coatings, before it flakes off. But when you can get that to 350,000 or 400,000 miles, you're going to see the thermal efficiency of the engine go up by probably, 8-10%.
Wow.
And when you're starting out from a base thermal efficiency at 28, going up 8%, that's huge. That's a 35% increase in fuel economy. Not to mention power. It's going to be huge.
Here's a good point that you were talking about the screws. This is from Racer D. The other problem with the bowl screws, they do not have enough thread engagement. So You don't need
I
to
agree.
torque them. Don't go tighten them too. People always
No.
want to strip them. You know?
Don't prove your manhood. Don't prove your manhood. Just snug.
Yep. I'll tell you the other thing I found with Holley Carbs is the throttle blade adjustment screw on the bottom. I mean, you want to make sure that you can open that up. And I think you mentioned that about opening it up enough.
Yeah, it's in here about making sure you open that up so that the
transfer slot, you can see the
transfer slot. Just you can just see the transfer
Yep.
slot at the bottom of the hole.
Because I've had my car where before I knew that the thing would not idle right. It wasn't idling high enough. You know, I'm like, what is going on here? And then somewhere along the line, I think I have a Holley book I read in or something, and did that.
And if they haven't adjusted it, the damn thing sticks in there. You know, that's the
Yeah.
problem. And Holley had at one time a special tool. It was like a little ratcheting box wrench with
I must saw that before. Yeah.
And you
get underneath it. Yep.
Yeah, you didn't even have to take the carburetor off the engine in a lot of cases. You went right in there and you could adjust that. Yeah. I used to have one.
That's why I don't know. That's why the Q-Jet was always the best street car. I don't know.
No, I don't. I totally disagree with that.
The only thing I liked about it was the big secondaries. When you nailed that thing.
Yeah, but see if you did a dyno curve on that, you see what happens is the airflow through the primaries would get really high and the carburetor would start to go a little bit rich, but you had to hold the air valve closed long enough so that as it opened up, you didn't get that hesitation.
Okay.
If you felt that hesitation, you had a torque loss right before that hesitation hit, and you didn't even know it. And you plot the horsepower curve, and it would go up and then it'd jump up when that thing came on. You want a nice flat. We even saw that on Holley spreadboard carburetors. I mean, ideally, you want the primary and the secondaries to be fairly equal, so when they come open, they don't shock things.
Right. Okay. Let's see. I'm looking at the time now, 8:52, because we can get into this a lot more. And I told my wife, I said, we're only going to talk 2 hours because you and
That's
I
fine.
we could talk for hours. I think we just skimmed this. What I'm going to do is make this data available, and then we'll revisit this to get into more details.
Yeah, that'd be good.
Kind of just skim the surface. And
if at some point you want to talk about, things about building engines and stuff like that, just like I talk about setting your cam end play and all the other stuff, how critical that is on some engines.
Now here's something. Let's see what's.
Yeah, there's some. If you put your coolant into the head first, you're cooling the heads down. That can help you in detonation when you're getting into really high compression engines, like what we're, in a drag motor, like what you're doing with a filled in block and stuff like that, pro stock, that's not a concern. But for certain limited types of situations, it could be a benefit. I like to, a lot of our circle track stuff, we ran filled the block halfway. We didn't run coolant throughout the whole block. We'd fill the block about halfway with rockite and stuff like that.
I mean, all the cooling comes from the heads anyways, you know what I mean? They were saying top the block. Now here's something I don't know much about, but you have to understand how to tune primary needles. You can adjust them with the engine running.
Yeah, you got to adjust them with. When you say the primary needles, I'm assuming you mean mixture needles. Yeah, you want the engine has to be running, and it needs to be warmed up.
They always say the mixture. Oh, it's 1.5 turns.
You can't go by that because that varies with the size of what's called the idle feed restriction in the metering block. And it also varies with the vacuum that you have at idle based on the lobe separation angle of the cam and the duration of the cam.
Yeah. Couldn't buy the Holley tool, so I ground an Allen wrench.
Well, that's what you do. I've made a lot of tools in my life.
That's funny.
Take a torch and bend the end of a box and heat it up and heat a box end up and bend it to where you need it to be.
Now this guy, he's done a lot of Engine Masters stuff.
Mhm.
Racer D. Did reverse cooling on my winning 2002 Engine Masters, cooling from the backward, frontward, and top down.
I can see where that would work.
Let's see what else. We
Again, you know, it's what you're trying to do. You know, I mean, let's face it, that Engine Masters competition, that's racing dynos. You know, I mean,
Sure.
you're racing dynos. That's
At RPM limited area,
yeah,
you know.
yeah, that's a different thing than racing the vehicle. I mean, there's, you know.
Mark, you a fan of big carbs versus small carb for economy, power, drivability?
You can make if the carburetor is set up right. We had about, when I worked at Holley, we had about 50 development engineers, okay, that did the calibrations of the carburetors. And the carburetor came down to who did the calibration. And, you know, I took a lot of pride in the calibrations I did. We even developed what was called a two-stage power valve. And I proved that you can have big carburetors. You would set up that power enrichment circuit right, you can get great fuel economy.
I remember them. Vacuum secondary carbs, any good for draw-through supercharger application?
Sure, I love vacuum secondary carburetors.
Are they problematic?
No.
There it is. All right, so we're gonna.
Most people don't appreciate vacuum secondary carburetors. I told you before, the street performance, the best I was ever able to do with a vacuum secondary or with a double pumper was make it run dead even with a vacuum secondary. In a quarter mile, a double pumper would always have 1 to 2 miles an hour on the top end, and it would feel stronger off the line. But if you looked at the ET, you know, it was right. A vacuum secondary was always right there. The best you could do with a double pumper was make it in an automatic car without a tricked out converter and all this.
Yep.
Maybe have a 10-inch converter or something like that, 11 or 10-inch. But best you could do with a double pumper was make it run dead even with the same size vacuum secondary. Now there's a problem once you get past 750 or 780 on a vacuum secondary. 800 vacuum secondaries don't work very well because the primary venturi isn't a good design.
I've had a couple of vacuum secondaries, and I didn't like them because they weren't double pumpers. You know, when you're a kid, that's all you hear.
And the double pumper feels better.
I know. Better. Those accelerator pumps kick in.
Yeah.
All right, so listen, we won't talk anymore. We'll end it now. I'll end it here, and then you and I will talk for a second afterwards. But I appreciate everybody tuning in to DragBoss Garage. It's been over a month since I've done any live chats, and a lot of that is just stuff going on in life in general, and it's tough doing a YouTube channel. You get kind of tired of making videos sometimes. You just want to live your life and not worry about it. And sometimes I go into times where whatever I got going on, I'll make a video when I get caught up. DragBoss.
People think it only takes 2 hours. They don't understand the preparation.
Oh, it does. It takes a lot of time. And like my family, I mean, that's why I got to put them first and keep them first. And I love you, Andrea, and my kids. So thank you for letting me have the time out here to do this, because I'm trying to build this channel, although I'm only about 80% effort. But that gives me my sanity. I don't want to be gobbled up by YouTube.
Never burn yourself out.
No, and I like to do it at my speed and give people some insight on what I like to do and what I got going on, because I got a lot of projects going on. And I don't watch TV, you know, for 13 years, so I have a lot of time not to be doing that. So I appreciate you guys being here. So we'll end it here. Stay tuned. I'm going to put this on. It'll be on for a replay. And then you guys in the comments ask specific questions. I'll make his data available on a video, plus his carb trick. We'll put it all in one video. And Mark will be back, and we'll figure out another plan on attack. So stay tuned, guys.